All right, today we're on 1.5, applying those equations, and we're doing day 4. So we've got mixture problems. So our objective today is here. We're going to solve problems involving mixtures. All right, so again, those problem-solving steps we've been talking about. Read the problem carefully. Plan and organize the information. That's what I'm really stressing, okay, in these sections is to read it carefully and organize the information so that you can come up with a plan and solve it, okay? All right, so today we're talking about mixtures. When I'm talking about mixtures, I'm just mixing anything together, okay? We can be mixing, making a trail mix and mixing M&Ms and peanuts and raisins together. You could be making cookies and mixing flour and chocolate chips and sugar together. You could be mixing anything, okay? So when we're talking mixture problems, it's just any combination or mixture of things. All right, so let's jump down to example 4. You notice we still have a chart here to use, right? The chart is not going away, but now you have to fill in the information that you need because it varies per mixture problem. So a fruit punch is made by mixing an orange drink costing 89 cents per liter and a lemon lime drink costing $1.19 per liter. How many liters of each must be mixed to produce 30 liters of fruit punch valued at $2.18 for a 2-liter bottle? Okay, so there's a lot of information in here. So we're making fruit punch, okay, and it's made by mixing orange drink and a lemon lime drink. Okay, so those are the things that are going to go here. Fruit punch is our final product, so it's going to go at the bottom. And then we can put our orange here and our lemon lime here. You could flip the order of those, but orange came first, so I've got lemon lime. All right, then we need to think about what information did they give us to go up here. So we know it cost $1, or it cost 89 cents per liter for our orange drink. So right there we have amount of money per liter. Okay, so we have a cost, but it also tells us that we're measuring in liters. Okay, and so those could go 2, or we could fill up 2 of these right here. Okay, so we could have the number of liters used, and we could have the cost. So you could put cost, or you could put like dollars per liter, however you want to do that. And then what would that last column be? Just kind of think back to day 2 when we had the motion problems, right? We always had like distance times, or rate times time equaled our distance. We want a similar thing here where this, if we multiply these 2 columns together here, the number of liters times the cost, it's going to give us something. What would that give us if we multiplied the number of liters times the cost per liter? All right, it's going to give us the total amount of money. Okay. So you just figured out the 3 labels that we need there. That's pretty awesome. All right, so I'm going to change up colors here. So we know the orange drink is 89 cents per liter, so that's going to go here. And the lemon lime drink costs $1.19 per liter, so our lemon lime cost, is $1.19, pardon me. So $1.19. And we need to know how many liters of each must be mixed to produce 30 liters of fruit punch. So our fruit punch, we want 30 liters, and we want it valued at $2.18 for a 2-liter bottle. So that's tricky. So this is $2.18 for 2 liters. So that is $1.09. Okay, per liter. So we've got to do that math. All right, so how do we know how many liters we need? A fruit punch is made by mixing an orange drink costing 89 cents per liter and a lemon lime drink costing $1.19 per liter. How many liters of each must be mixed to produce 30 liters of fruit punch? So how do we know how many liters of orange and lemon lime we need? Did it say it was an equal amount? Mix an equal amount? Nope. Doesn't say that, does it? So how do we know? We don't know, right? Like we have no idea. So we just have to, like we know we need 30 total. And we need some orange, okay? So I'm gonna put an X there because we need some orange, okay? But we also need some lemon lime, we just don't know how much. Except that we do know if we need enough to make 30 liters, okay, total. So we need some orange and we need enough lemon lime to make the 30 liters total. So this is just gonna be the 30 minus X. We're going to take however much orange we use, we're going to subtract from 30, and that'll tell us how much lemon lime to use. Okay, so some good stuff there. Okay, so then again, just like we talked about, we're taking our number of liters times the cost is going to equal our total. So for our orange, this is going to be 0.89x. For our lemon lime, we're going to multiply the number of liters times the cost. So we're going to get $1.19 times the quantity, 30 minus X. Okay. And for the last one, we're going to get 30 times $1.09. Okay, which is, by the way, $32.70. So $32.70. My zero you may not be able to see out there. Okay, so how am I going to write an equation out of this? How am I going to write an equation? Okay, well remember, we are taking the orange and we're combining the orange and the lemon lime together, right? We combine these to make fruit punch. So that means that our orange plus our lemon lime, I'm going to put it as LL, equals our fruit punch. So we're going to take our total for the orange, so this 0.89x, we're going to add that to our total for the lemon lime. So we're going to add the $1.19 times the quantity 30 minus X, and it's going to equal our total for the fruit punch. So it should equal $32.70. There we have it. Now we've got our equation, we can solve it. All right, so we've got to distribute here, so 0.89x plus, let's see, $1.19 times 30 is $35.70 minus $1.19x equals $32.70. All right, so we're going to subtract $35.70 from both sides of our equation. We're going to combine some like terms. So 0.89x minus $1.19x is negative 0.3x. And that's going to equal 32.70 minus 35.70 is negative 3. We're going to divide by negative 0.3 on both sides and get x equals 10. All right, so then if x equals 10, we're going to put that back in this chart up here. That means orange needs 10 liters and lemon lime is 30 minus 10, so 20 liters. And is that our question, right? How many liters of each must be mixed? Yes. So we need 10 liters of orange, 20 liters of lemon lime to make a fruit punch drink. All right, so there is a lot of information to organize, and you have to be able to, like, this is where geometry is coming in. I know that you're like, there's no shapes here, Miss Talbert, but I've told you repeatedly, geometry is about your inductive and deductive reasoning. It's looking at a problem, it's reading a situation, drawing conclusions from that you can apply. This is you applying those skills that you worked so hard on in geometry last year. And being able to pick out important information and draw conclusions from that, okay, and then apply those. So don't think geometry went to a waste. It did not. We're just not using the shapes part of it today. All right, example 5. A chemist has 12 grams of a 3% salt solution. How much water will he need? How much water will need to be evaporated from this solution to obtain a 5% salt solution? Okay, so we don't have a whole lot of information here. It doesn't seem like, but there's enough to do what we need. Okay, so we have a chemist has a 12 kilograms of a 3% salt solution. How much water will need to be evaporated? I know that this doesn't seem important, but this is. How much water will need to be evaporated from this solution to obtain a 5% salt solution? Okay, so we have to think about this. I don't know if you've had chemistry yet, or maybe you're in it, but we have a 3% salt solution. Okay, so in this mixture, right, you've got this mixture of water, and in there, so this is water, 3% is salt. Okay, so it's 3% salt. We want to go from a 3% to a 5%. The only way to do that is for the water to evaporate, for there to be less water, right? So in that case, we would have less water. The salt doesn't evaporate, the water does. Okay, but if we have less water, it means our salt solution, there's more salt in it. Okay, so that's what we're trying to get to. So that means that for our things here, we have a 3% salt, okay, solution, and we're messing, right? We want the water to evaporate. So H2O is what we're looking at there. Okay, our water has to leave so that we can end up with a final 5% salt solution. Okay, so those will be our 3 things of how we're getting our mixture here. We're dealing with 3% salt and evaporation of water to get the 5% salt. All right, then we need our labels for our columns. So we know one of them should be kilograms, right? Because we have 12 kilograms. So this is, we'll do number of kilograms there. And then of a 3% salt solution, percent is our other one. Okay, this is going to be percent salt. All right, so again, if I take the number of kilograms and I multiply it by the percent salt, what's that going to get me over here? It's going to get me the kilograms of salt that I need, so I could weigh it out. Okay, that's going to give me my kilograms of salt. All right, so let's plug some numbers in. Chemist has 12 kilograms of a 3% salt solution. So we've got 12 kilograms, and we know it's 3% salt. However, well, it depends on how you want to do that. I was going to say, you could leave it as 3, or since it's a percent, you could change it to 0.03. But let's try it with just 3. It's 3% salt. And we'll go from there. That's going to change my numbers a little bit, but it'll be okay because I did mine differently. Okay, then water. How much water will need to be evaporated? Ooh, do we know how much water will need to be evaporated? No, we don't know how many the kilograms, so we can put a W in there because we have no clue. However, so then what about the percent of salt? What's the percent of salt in water? Like sometimes that's it. You're like, it doesn't say. It doesn't say that there's any salt in there because you know this, right? Like when we're talking about water, is water a salt solution? No, it's not. So what's the percent of salt in water? None, okay? It is 0. That's the thing. It's just the water that's evaporating, not the salt. Some of these are very self-explanatory when you really think about them, okay? So then how about our 5%? Solution? How many kilograms are we going to, what's the number of kilograms we're going to have of that? We don't know, but we do know we started with 12 kilograms, right? And the water evaporated, so that means we're going to have less. So we're going to subtract these two things. This would be 12 kilograms minus the amount of water that disappeared. Okay, that's handy. What's our percent salt solution in our 5%? It's 5. Nice. All right, and the way that we get our third column down here, if we don't have anything filled in, is we multiply. So we've got 12 times 3 equals 36. W times 0 equals 0. And then 12, the quantity 12 minus W times 5 is going to equal 5 times the quantity 12 minus W. Okay, I always like to put my number in the front of the quantity, so I can say 5 times the quantity, always. Okay, then how do I take this information and make it into an equation? What's happening? What is happening? Well, I have the 3% salt solution. Okay, I'm subtracting the water to equal the 5%. So that's what I need to do. Okay, I'm going to take my 3% salt solution over here, 36. I'm going to subtract my water, which I know sounds crazy. 36 minus 0 is going to equal my new solution. So the 5 times 12, times the quantity 12 minus W. Again, I know it sounds a little crazy, but I promise it's going to make sense. So 36 minus 0 is 36. 5 times 12 is 60 minus 5W. Okay, then we're going to subtract 60 from both sides. We're going to end up, that's going to equal negative 24 equals negative 5W. And divide by negative 5, divide by negative 5, and that's going to give you a positive 4.8 equals W. So we need to plug that back in here. So that would be 4.8 kilograms of water has to be evaporated, right? Or well, it does, but I guess I didn't have to write that there. And we're going to have 12 minus 4.8. So that's going to be 7.2. So we'll have 7.2 kilograms of 5% salt. Did we answer the question? How much water will need to be evaporated from the solution? Oh, so our answer is actually just the 4.8 kilograms of water needs to be evaporated. We didn't even have to figure out how much 5% salt we needed, right? So that's the thing. Like, I want you to recognize sometimes you can find too many answers as well. Okay, very good. Like, I could ask you this question, how much solution would remain? Well, 7.2 kilograms. All right, so again, any mixture at all is going to be using, like, you can use the same setup. Okay, so we're going to have lots of those. Let's go to the back. Example 5.2. How many pounds of peanuts costing $1.90 per pound and raisins costing $2.50 per pound should Mr. Bruckner mix to make 12 pounds of a trail mix that costs $2.05 a pound? All right, so we're combining, let me change my color here. We're combining peanuts and raisins to make trail mix. Okay, so I'm gonna have peanuts and raisins, and we've got trail mix. Or you could just put mix. Like, again, what you put in these columns or in these rows, how you label them, is not always like the most, especially this, section here. It doesn't matter how you label them, as long as you're getting the information you need in there. So then we're going to look at, okay, we know that they cost $1.90 per pound. So we're going to need the cost. So again, you could switch these up. It doesn't matter. You could put the cost here, okay, which is your dollars per pound. But that means you're also going to need the number of pounds that you have. And then if I have the cost times the number of pounds, that means I'm going to have the total. and that's just in the dollars, right? So you've got your chart like set up to fill in just by knowing that one piece of information. Okay, so our peanuts are costing us $1.90 per pound. The raisins are costing $2.50 per pound. We want to make, how much, okay, should Mr. Bruckner mix to make 12 pounds of trail mix? So we've got our trail mix and we want 12 pounds, so that's going to go there. That cost $2.05 a pound. So his mix costs $2.05 a pound. Okay, awesome. So kind of like the fruit punch problem. Do we know how many peanuts or how many raisins to mix? Does not give us a ratio. Doesn't say anything about twice as much, nothing. So we just pick one. Okay, give one a variable. So since peanuts is first, I'm going to give peanuts a P. And then what is my raisin going to be? I'm going to put this much peanuts, so how many raisins am I going to use? Again, think back to the orange lemon lime fruit punch mixture. If we want 12 pounds total, we're just going to do 12 minus P. Okay. Awesome. All right, so now let's do some math. My total here is going to be $1.90 P. Here I'm going to have that 250 times 12 minus the quantity 12 minus P, and then 205 times 12 is $24.60. Okay, so we've got all the information we need here. Now we have to think about getting the equation. What am I doing? Well, my peanuts are being added to my raisins to get me my trail mix. So that's how we're going to set up our equation. My peanuts are 190p plus my raisins are I'm going to just go 2.5. I'm going to shorten that down, times the quantity 12 minus p equals my trail mix, which is $24.60. All right, so this is going to be 190p because we've got to do some distributing. So 2.5 times 12 is 30, and then minus 2.5p equals 24.60. I'm going to subtract 30 from both sides. Okay, but at the same time, I'm going to add my like terms. 190p minus 2.5p is going to be negative 0.6p. That's a decimal. And that's going to equal 24.60 minus 30 is a negative $5.40. Again, I'm leaving the zero off. Like I know it's money. I'll put that back on at the end, but still showing my work. All right, I'm going to divide by negative 0.6 on both sides so that I find out my P equals 9. All right, and then I got to plug this back in to my chart here. So I have 9 pounds of peanuts, and for my raisins it's 12 minus 9, so 3 pounds of raisins. Did I answer the question? How many pounds of peanuts and raisins should Mr. Bruckner mix to make? So yeah, 9 pounds of peanuts and 3 pounds of raisins. I did answer the question. Awesome. Okay, you'll notice I'm going a little bit quicker, hopefully, because I feel like you should have a better understanding about how to do it. So let's finish up with our last problem here. Example 5.3. Mr. Briggs owns a small store and is planning a back-to-school special on selected school supplies. He wants to put together a package of pens and pencils. If pens sell for 39 cents each and pencils sell for 50 cents, how many pens and pencils are in a set that contains 16 writing instruments and sells for $3.56 per package? Okay, lots of great information there. So we've got Mr. Briggs, he's got this small store, he's doing a special. He wants to put together a package of pens and pencils. Hey, there's our 3 things right there. It's a package right? It's a combo pack of pens and pencils. Ta-da! All right. We know the cost, right? The pens sell for 39 cents each. So we've got our cost here. So pens are 39 cents each. I need a decimal in there. And, well, yeah, I was like, I guess you wouldn't have to if you did it. We could do cents per each. If you did cents, you wouldn't have to put the decimal. Because sometimes I know you don't want to deal with the decimals, right? You'd rather have whole numbers. So that's cool too. It's kind of just how you set it up. As long as you keep it consistent, that is key. The pencils sell for 3 for 50 cents. Okay, so that's just going to be 50 divided by 3 for there. How many pens and pencils are in a set? We don't know. That contains 16 writing instruments. So the set contains 16. So we need the number of writing instruments is what they're calling it. Okay, so the number in the package is 16 here. We don't know how many pens and pencils, however. All right, but we do know that if we take the cost per each and how many there are, we're going to get our total. Okay. And we also know that this set sells for $3.56. So we know the total here. Pretty sweet deal, right? We like it. Okay. So how about our pens and pencils? Do we know our writing instruments? Do we know how many pens or how many pencils? We do not. So again, we have to pick which one. So we want to say, all right, well, I want X. It's going to have X number of pens. So how many pencils is it going to have? Well, if there's 16 total, it's going to be 16 minus X. All right. Now, you might be stressing because we don't have this one filled out. You know what? It doesn't really matter that we don't have it filled out. We always need this column. Our goal is to get the total column filled out. So we don't have to have this one filled out necessarily. We just have to have our total column filled out. So it's okay that, because we also don't know how much it costs per each because they each cost a different amount. So again, it's totally fine not to have anything there as long as we have a total. All right, so our total for the pens is going to be 39x. And for our pencils, that's a fun number, right? It's going to be 50 thirds times the quantity 16 minus x. All right. So now again, I do want to keep 50 thirds. Like some of you might want to change that to a decimal. Okay, but if you change it to a decimal, currently it's going to be more inaccurate. Like you're going to get a poor answer. And I'll show you what you know what to do with that. You probably just haven't done it in a while. Okay, so how do we set up our equation? So think through that. Okay, we're taking our pens and combining them with our pencils, right, to make up the package or the set for the back to school set. So that's what we're going to do with our problems over there. We're going to take our 39x, because that's our total for our pens. We're going to add it to the pencils, the 50 thirds times the quantity 16 minus x, pardon me, is going to equal the $3.56. Okay. Now, here's the thing. If you don't want to deal with this fraction, which I don't blame you, you don't have to, you can eliminate the fraction. It's probably been a while since you've done that, but you take that whole quantity and you multiply it by 3. Take the whole equation, right? Multiply it by 3. Your numbers are going to get bigger, but you don't have a fraction. So it's up to you. So 3 times 39 ends up being 117x. 3 times the quantity 50 thirds, the 3 cancels here with that 3. Remember, that's the point. So you just end up with 50 times the quantity 16 minus x. Okay, because remember, you distribute here, we're distributing to each, we don't distribute it inside of here, we're distributing it to the number that's going to be distributed. Okay, and then that equals 3 times, oh, timeout, timeout. This is where we had a problem. Back the train up. Because this was cents, right? Our total has to be in cents. I didn't catch that. So this is going to be 356 cents. That's what we've got to watch. Ah, I did it again. I'll make it part of my 5. 356 cents. So you do have to watch for that. I'm glad that I made this mistake and caught it so you guys would be aware of it. Do you understand? Like here, since I made it cents and we just wrote 39, this had to be 356 cents. Otherwise, this should have been 0.39 for this to be $3.56. Again, totally up to you how you do it, but you do have to keep them the same or you're going to get into problems like I almost did. All right, so 3 times 356 equals 1,068 cents. All right, now I'm ready to distribute. So I'm going to have 117x plus 50 times 16 is 800 minus 50x equals 1,068. Okay, I'm going to subtract my 800 from both sides. To balance, I'm going to do some math here. Combine my like terms. 117x minus 50x is 67x. 1,068 minus 800 is 268. Divide by 67. And x equals, I'll have to write it over here. I ran out of room. X equals 4. Plug that back in to your chart. So I need 4 pins, and 16 minus 4 is 12. So I would need 12 pencils in each pack. All right, let's see if we answered the question. How many pens and pencils are in a set that contains 16? Okay, so 4 pens, 12 pencils. I answered it. Does that actually equal 16? Yes. So we have our answer right there. 4 pens and 12 pencils. All right, that is it for the 1.5 day 4, looking at mixtures. Have a great one, and I'll see you tomorrow.